Okay, okay. Okay, so the do while loop, as I was saying, it executes at least one time, and then you can see here, right? So you see like the condition is after the loop code executes, right? So again, do something. So we have some code, and then we need some code that'll eventually change this Boolean expression to false. But in here, we can have other code that executes at least one time. And it'll keep on executing as long as this evaluates to true. And once it's false, then the loop will exit. Right here, notice semicolon. It is required 100% of the time. If you omit it, you'll just get an error that it's not very helpful, right? So it's always better to just mind the examples, right? So remember, the while portion requires a semicolon. The while, notice down here, no semicolon. So please remember that. And if you just look at the examples, then you won't trip yourself when you're using a while or a do while. Okay, so prompt user. So what we'll do is we'll write some prototypes here. We'll just make them void, and then this one, oh, let's give it some meaningful name. Like this one will be the receivables function. And this one will be the payables, and this one will be the payroll. And that should be good enough. 3 options is fine. Okay, and then we can go ahead and copy them into the CPP. Make sure that we have the header. We do. Remove semicolon on all of them. Replace them with the open close curly brace. And we have to output some text for users. So we'll say IOStream. I don't have to use the using statement here on the CPP, but I'm going to be using the cout a lot of times, right? So if you're using cout like maybe one time, you don't have to opt for this convention. But if you're using it a lot of times, then we can just type cout as opposed to start cout every time we use the cout statement, right? And the code looks cleaner. So we'll just say receivables, and then payables, and then finally payroll. And I might have to rethink this one. I think. Well, I'll come back to it. Okay, so then we come back to the header. Let me see what I was thinking here. Well, write code for void, prompt user to loop until user opts not to continue. Okay, so I guess we'll stick to this one. Void prompt user with no parameters. Okay. I've usually kept the example very simple without this piece, right? So I may have to rethink this in a little bit, but for now, we'll stick with that. I usually just show the prompt user and then just show that the loop just continues asking the user for input. Okay, so do, I don't know the shortcut key for it to help me. Do while something, right? Semicolon. It's required. Okay, so I'm sure in Python you learned about scope, right? So if a variable is created here, so we create a character, and notice choice is a character, meaning one character. Single quote, single quote. This makes it a char or char type. So we can say, well, choice equals y. We'll keep it simple for now. So this variable lives from here all the way to right before the function exits. That's why we can read it here. However, if we move it into the do piece, notice right away we get choices not defined, which tells us, oh, okay, so this variable lives from here to here. Once it exits the do block, it doesn't exist anymore. That's the reason. So that's scope, right? That was loop scope, and this is function scope. So that's the reason we have to put it outside the loop. Okay. So prompt user, let me think here. We need one more function. I had created it somewhere else, but I'll create it here. Display menu. Nothing's stopping me from writing cout statements in here. Like I could just do cout statements to create the menu here, but it's a lot cleaner. It's a lot cleaner if I just have a function and then I can simply say display menu here, right? Fewer lines of code, and it makes it easier for me to read in the long run. Okay, so display menu void, and this one's just gonna display a menu. So we'll say like if you type 1, it'll be receivables, 2 payables. So then we are seeing that with functions we can break our code into logical modules, right? So we don't make the functions too small and we don't make them too big. Obviously, this one's kind of like, well, this one's small, but if it was receivables, it would have its own menu, maybe like at a customer, uh, bill customer, something like that, right? And then this would be like at like bill company, and this would be like at employee, right? And it would have like modify employee. It would have different options, but we're not going that deep. Okay, payables and payroll. Okay. Okay, so now I can display the menu for the user. So I display the menu and then I can say enter number from 1 to 4, I guess, right? Because 4 will be maybe exit. Oops, I forgot the semicolon there. Exit. Okay, so then choice will be a number now, right? So let me see here. How do we do this here? Actually, no. We leave that one there. Okay, so we need to capture a number. We don't have a variable, so we need to declare a variable here for menu choice, whatever the user opts to choose, right? So we'll default to, well, maybe we'll default to 4, but it really doesn't matter because they can't skip the CIN step. They have to go through this step, right? Okay. Okay, so how's this gonna work? Okay, it runs, displays the menu for the user. The user is prompted to enter a number. They enter a number on this statement. We save the number to menu choice, and somehow we have to determine which of these functions to call, right? So why do I keep on forgetting the semicolon? Display menu, receivables, payables, payroll. Okay, so maybe we need, okay. Yeah, I was thinking switch, but I'm debating whether to create, I was debating whether to create another function or not, but I guess I won't, just to keep it simple. Switch menu choice. Yeah, you see, because then notice our function all of a sudden is now like, whoa. But it should be manageable. This should be okay. So now we can say here like case one, then we choose the receivables. And then case two, payables. And case three, payroll. Should have stuck to typing. Okay. And we'll go ahead and put case four for exit. That way, if they enter anything else, we could just display invalid choice. So case four, we have to prompt them, right? We have to ask them, are you sure you want to exit? So type yes to exit, I guess. I'll just make it simple, type Y to exit. Okay, and then we can capture choice. Choice. And then if it's default, then we simply say invalid choice. Okay, so display the menu. Okay, I think more or less we have it. Okay, invalid choice. We assume choice is Y, but we have to eventually prompt them, right? Okay, exit. Type Y to exit and to cancel. They come in here. Okay, I think this will work. Any questions so far? Sure. Yes. And that is a good question. The compiler will look for choice in its immediate block, which is switch. It finds it, but if it didn't, it doesn't find it, right? Declared, I mean, it doesn't find it declared. So then it comes to the next block, which is a do block, and it's not defined. So then it comes, to the next block, which is a function block, and it finds it. If it didn't find it here, then it would go to the global scope and it would look for it, kind of like that const variable that I created for Pi. It would look for it somewhere here to see if it will find it. If it didn't find it, then it would just give up and say, no, I can't find that variable. You can go outside in with namespaces, but kind of like we start, like we can create our own namespaces. But I usually shy away from that in this course. But if you really wanted to, you could create your own namespace. Yeah. Mhm. Okay, so let's see. So prompt user, maybe prompt user should be run menu, right? I think that, I don't know. I think that's what I was thinking. Okay, again, all void functions. So it's really difficult for us to test this. Like we can't really test unless we have functions that return the value. But this should be okay. It's just a menu and we can run through it to see if we're gonna be okay or not. Yeah, I defaulted to Y for receivables, payables, and payroll so that it can just keep on running. And then once they want to exit, then I ask them, do you really want to exit? Type Y. Because like from a user's point of view, like if I go into receivables and then I come back to the main menu, like I don't like if it keeps on asking me, do you want to continue? Then eventually I'm like getting frustrated, right? Because it's kind of like, why would I want to exit? You know, I was in receivables, now I want to go to payables, you know, or now I want to go to payroll. So that's what I was thinking here. So the only time we ask him, like, oh, you type exit, so are you sure you want to exit? And that's why I opted to do this. I'm pretty sure there's other ways we could handle it, but that's what I was thinking. Yeah, because the logic is like we just want to prompt them, are you sure you want to exit? You know, because maybe the program takes a while to load or whatever, right? And for receivables, like if they go to receivables, and then we're just gonna let them go to the receivables, and then they're gonna be prompted with some other menu. But here they're just gonna see receivables. And actually, maybe I should put something here, like for them to type something to continue, because what's gonna happen, it's gonna go to receivables, and then it's gonna display the menu right away, this menu for us right away. But that should be okay for the six. Yeah, yeah, it should display receivables, and then maybe we should say you are in receivables module, and maybe put a new line character at the beginning too. And again, this is just simple example, like a skeleton example. You are in payables module, just to show you how you could possibly use this. You are in payables module. And if it doesn't work, then we can fix the code, right? So, but I in it, it should work. Because this one will always ask them. So we stop here, we're always asking them to pick something. And then we display, it's still Y, it should come back and display the menu again right away. Okay, so let's see what happens. We go to main, and we want to include do while. And maybe that should be run menu instead of prompt user, right? Prompt user, I'm not sure what I was thinking with that example. But this one, a better name would be run menu, because then or run program. Program menu. Okay, so let's see. CMake, SRC, examples, repetition. Okay, so let's see what happens here. Okay, so enter number from 1 to 4. So then we enter 1, right? If so notice here, like you are in receivables module, we go back and look at that code. What does this code do? All it does is display you are in receivables modules, and then the code exits. Like, but if this were a real program, then this would be another menu where the user would select some option and then they'd go into some other function. But I think for this example, that should be good enough, right? So then it's asking us again, like to select payable, to select an option, right? We'll say number 2 for payables, right? So you are in payables module, and then it exits, and then receivables, the main menu is displayed again, and then we could say like 3. Uh, did I put payables twice or what? Let me see, or did I call the wrong function? Payroll. Oh yeah, so you are in payables, but it should be payroll, right? So I put the wrong spelling there, but that's fine. So then finally we say, okay, so let's try 4, and then type Y to exit and to cancel. Actually, it should be the opposite, right? So, so if I type Y, it won't exit because the code is while it's equal to Y, right? So it should have been while not equal to Y. So if I type Y, it continues, or did I break my code? What happened here? What happened to my cursor? Type Y to exit, and the thing is, it's not even doing anything. So CN choice Y. So then it should have displayed the menu again according to this code because it didn't exit. So let me, wow, it doesn't even let me control Z. So I really did a number on this one. Control C usually stops the execution, but it didn't. So let me, can I stop it from here? No. Yes, okay, so let me exit this and then let me open code again. And let me walk through the code again. I'll just walk through that branch before I run it. Okay, so I display the menu and then I type 4, and I guess type Y to exit, but we know this is incorrect. This should be not equal to, right? So I typed Y and then it just didn't work with me. And there's the break. So it should have broken the switch code and jumped over here, but that didn't happen. Oh, choice. Okay, so Okay, so let me run it again like that. I don't see. This one looks okay. Let me run it again. So this time I'm just going to select the exit. See what happens. Oh, wrong one. Okay, so let me select 4. So we know we can't type Y if we want to exit. We can type Y if we wanted to continue. I didn't fix the code. I just want to run the program the same way it was before. So if I type Y, it should continue. So let me see. I don't know what happened the previous run. Let me type 3. Payroll, you are in payrolls or payables payroll. Oh, I really messed that one up. So, okay, let me do 4 now to see that breaks it. Enter number from 1 to 4. 4. Do you want to exit? So if I type Y, it should not exit. So if I type N, it should exit. So it's working now. Let's see here. 4 to exit. 1, 2, 3, 4, and to exit. I don't know what happened. I guess somehow I lost my cursor. Let me fix this, right? So um, we'll make this one more readable, right? Okay, so I'm just making it more readable. So now type Y to exit and to cancel. So this should still work. Running terminal. I don't hear any beeping. So if you have questions and I'm not acknowledging, you can just start speaking. Oh, okay. What did I do? Yeah, because I only used it one time. And see out, I'm using, well, actually twice, right? But see out, I was using it like a lot of times. See out, see out, see out, see out, see out, see out, see out. So that's why I did that. So it looks like my program's still running, but I exited. Hmm. It says I exited. Let me see. Run 4. So it exited. Let me try to run it again from the build. Usually when you get that permission denied, that means your program's still running in the background. And that's what's, see this error, permission denied. So I don't know. I mean, it's telling me that it exited, so I don't know why it's not letting me. So if a program's running, you can't override it, right? That executable file, so that's what it's telling me, that it can't create the new executable. Let me go to CMake. SRC. Run in terminal. So yes, I've lost a lot of hours of my life debugging stuff, right? So, but those became a lot fewer once I started using test cases. So, okay, so terminal, run in terminal. Nope, cannot open. Output file, permission denied. It's still giving me that same issue. Hmm. Let me navigate to that one. Okay, documents. So that's a strange one. Let me go here to repetition. Actually, not there, right? It's to be here in the build. SRC examples, repetition, do while. So it's not letting me delete that. A file is open. Oh, that's weird. Hmm. Usually if I close Visual Studio Code, then that file's gone. More details. Oh, it's there. And task. That's strange. Okay, so let me go back. I don't think that's ever happened to me. Usually I close Visual Studio Code and it closes the executable for me. Okay, so now we can go back here. Examples. And run it. I have to wait for the configuration. Okay. Okay, so exit, yes, right, that's with the new code. So let me go ahead and fix this payroll module. And as far as the C out, like if usually like one or two times is acceptable, right? Like stud cin, stud cin. But if you're picky, or if the development shop's picky, then they're gonna want to do say stud cin, and then you can just do this. And most development shops opt for this convention because the code's a lot easier to read without those double colons. Questions on the do while? No questions? They tell me to wait like for 30 seconds, but then that's kind of like awkward silence, right? So, okay. Hmm. Yes. Hmm. No, no, this is mainly just for humans. so that someone can read the code without cussing at me. Yeah. Hmm. Yeah, it'll work. Hmm. Yes. Yep, it'll still skip that white space and go to the next line of code it finds. Yeah. Hmm. But don't do that. This one's here. You mean like if it's like this or what? Or I guess I didn't understand your question. Or like this? Yes. To the compiler, it doesn't matter, but it'll matter to you if you're the one supporting the code, and it'll matter to your team, right? So they'll usually have like coding guidelines for indentation and white lines or white space. So you'll follow their convention. Hmm. Was that David? Or yeah, yeah, yeah. I mean, yeah, yeah. So that's what I'm saying. Like to the compiler, don't care, but usually some human cares, and usually that human's the one maybe employing you. So you just have to go with what they say. Okay. Okay. So I didn't have one for the forest. Let me see. Okay. I don't want to go to strings yet to this example. I'll just create another example in this for space. So in Python, like if you create a list, you could say like for item in list or something like that, right? Like you didn't have to write old school the old school for loop to iterate through the string. Like you could just, or you didn't have to do something like this, like we did for the while loop, where we index the string and access each character at a time. Instead, Python has the range for, where it makes it very easy for you to just say, hey, for each item in list, and then in the for loop code block, you do something. You either display or do something, right? So in C++ 2011 or C++ 11, they added that functionality with the ranged for because they're trying to compete against those other languages, right? So I'll come here and I'll go to the library files here, and then we'll just say also display text, and we'll put a string here, and obviously I have to come back up here, include the string header, and then I help my compiler identify the string. Okay, so stud string. And we will use the for range loop to iterate through this string and just display it to screen. We'll just echo it to screen. So we come here, remove the semicolon at the open close curly brace, and then we can say for let auto help us for a character and string. Again, these braces are optional, but it's probably better for you in the long run if you just go ahead and include them. And here we can say cout the character, one per line. So notice this is the for range. So for auto, what is ch? Well, from this variable, it's like, okay, I'm going to loop through the string, so I'm going to be grabbing one character at a time. So it makes this variable a char type or a card type. So then here, like if we send in Mary or Joe, then it's going to be grabbing one character at a time for from the string and displaying it to the screen, and we'll be adding a new line after each character. So we can go to the main and comment this out for now, and then we'll say display text. Text. I'll fix it. So display text. That's not what I wanted to do. Display text. Okay. Go to main. Why is that thing there? Okay, display text. I can say name equals Joe. Name. And then we go back, and before we run it, we send in Joe, so str is Joe. So for each character in the string and the str of string type, uh, grab each character and do something with it in each iteration, right? So the first letter is J, displays J. We add a new line, and the next line it's O. We add a new line, and then on the third line, it'll display E. Okay, so that's what we're doing, and we're simply demonstrating that C++ has tried to make it very easy to work with strings or lists, right? So let's go ahead and give this a run. So we go here, run in terminal. Right, so here we are, Joe. And if you're iterating a string in the future, a list, unless the assignment calls for it, then always opt to use the for range because it's less error prone and it'll allow you to write fewer lines of code, right? Okay, so what if we want to change the values of this variable? Say we want this instead of to be Joe, we want it to be caps, right? We'll just, or whatever. I'll just put Z because I don't want to write extra code. So what if I just want to say, well, I just want to overwrite every single character with Z, but let me go ahead and do it after I display. And then I want to see what it is after the loop. And maybe before the loop. Okay, and then we go ahead and execute this piece of code. So notice that although we have this here, and it's not a double equals, right? So we are trying to assign the value to the character. But it is Joe before the loop. It is Joe, obviously, because we're displaying before we try to modify it. But then after the loop, it's still Joe. So we'll talk about why this is the case. Questions on this? So, right, yeah, that's what I was going to say, right? So if I was a student, that would be my first question. Hey, wait a minute, why doesn't it work? And then if you think about it logically, the only logical response is like something in here is working with a copy of something. That's what I would conclude. Like, oh, it's not working with the string. I'm modifying a character. So maybe the string JOE, when I say, hey, for each character in the string, then it's like, yeah, J, but it sends me a copy of the value. So then I'm working with a copy, and that's why when we exit the loop, this region of memory is not affected because the compiler's sending me a copy of each character on the string. So if we're having a difficult time picturing this, and we can come here, and we'll go here to the string because it's there, and then we'll say, oh, okay, so let's see what is happening. Uh, so according to what the professor told us before, a string is on the heap, that the characters are on the heap, and the stack holds the address of some address on the heap. So say Joe is here, J-O-E, and this is maybe like Y100, Y99, Y98, Y97, Y some large number, okay, Y96, and name, right? So name is there, and name points to the first address of the list, JOE, which is a list of characters. So then we will see Y98 here if we had like memory vision into the computer. So then, assuming we're in the loop and we want the character J, so then we're like, oh, so maybe CH variable is on the stack. So when we're looping, it's kind of like, oh, okay, J, yes, I will give you J. Here is J. And then my code's like, hey, change J to Z. So it is changing it to Z, but it's a copy and not the original, right? The original's over here. And then the same thing happens for O, and the same thing happens for E. They're changed temporarily to Z. CH only exists, and we go back to the code, while the loop code runs, right? So while this piece runs, J exists. Once it exits this, then J no longer exists. This memory address is released, but then it's captured again to CH for the letter O, and then it's released after the loop, and then it's used again for E. So that's why this stays the same. And that concept is known as, I guess I'll write it here, by value or by copy. So iterate. So what happens, we get a copy of each character into CH, exists temporarily, and then it doesn't overwrite the original. So then what's the next question someone should ask? How do you modify it, right? Yeah, that's the next question. Be like, sir, well, okay, but so with the concept known as a reference, and I will show that. I'll show you, and then I'll explain it. That simple, that symbol represents the concept of a reference. Okay, so what is a reference? So we come back here. So the reference means, for example, here, like name has a reference to the first character address, Y98, right? So meaning it points to the original memory of my list JOE. So now by using this, now I'm like, okay, so each time I loop, don't give me a copy. Don't work with the copy, work with the original. So the original reference. So then you'll see that JOE right now will be modified once I execute this code. So I come back here and then I run in terminal. And notice now, like we have JOE, should be JOE because we are displaying before we modify it. And now at the end, notice that it changed. Okay. So that is the concept of a reference. So let me make this to the original example. Okay. So and then I'll jump to, yeah, I can talk about references today. And references are very important to understand what's happening to function parameters. Okay. So far we've used functions. I've just assumed that you all more or less know how functions work. But now we're going to take a deep dive into why is it that function parameters work and what can we do with those parameters to do different operations to those parameter values. Okay, so we go here. So functions. I'll skip void for right now because references it's a little more interesting than a void function. Okay, so let me do something. I have to go to examples. Oops, not here. Examples CMake. So I have to go into the CMake list, and looks like I opened all of them for business. Okay, all the examples. I was checking to see if they had an ampersand, but I guess I don't. And let me look at the test examples CMake list. Okay, so all of them are available. Okay, so then I can come back here, functions, references, main. And we will start without a function just so that I can show you how this works. Okay, value equals 5. We need IOStream. We'll be using cout a few times. Maybe if I say memory address of value is I think here. Okay, memory address. Okay, so they also call this reference operator the memory operator because you can query C++ and ask it, where was this variable value created in memory? Can you give me and display the memory address for me? And then without the ampersand, it's just show me the value that this variable has. Okay, so let's go ahead and run this. Okay, they're on the right one. Do while. Oh, here, okay. And obviously it's hard to read because I didn't add a new line. Okay, let me run it again. Okay, so memory address, uh, sorry, put it in the wrong place. It should be over here. And we run it one more time. So notice memory address of value is some hex number. I'm not a hex guy, so, but it's some large number in memory. And now you can appreciate why I just go ahead and just say like some Y number at 100, right? Because we are used to working with decimal values. And the value is 5. So if we look at the stack, then assume this would maybe be 61FF0 or 0C, and the value would be 5. So then assuming this would be the address for value, this would have the number 5 stored here, right? So if we want to make that more readable, then I can just come over here and just say, okay, so let's say integer value equals 5, which is the same as auto value, right? This determines for auto what it is, but it's 5. So on the stack, assuming this was a memory region, and this would be, I'll just write the last 4 digits, FFOC, FFOC, and in here would be the value 5, and this is the stack, and there's nothing on the heap for an integer. Okay, it's just a simple, a fundamental type. So this is what more or less, like if we could go and peek into memory, this is what we would see. And okay, so any questions here? Yeah, yeah. So if that's a good question, right? So we go here. Um, I'm not even going to try to see what this hex is, but assuming this was like 100, right? And this would be another integer stored, then this would be 96, right? Because there's 4 bytes required for this guy, and maybe for another integer, another 4 bytes. So we would have like something ending in 100, and then the next one ending in 96. And depending on how the memory algorithm works, this may be 100, or this may be, I mean, 96 or 104. But usually it goes down. The values go down. Yeah, yeah, yeah. Usually what C++ does, like when you create a string, like they've surveyed like a lot of developers around the country, and I think they allocate uh, 8 slots. So you start with 8, meaning you can put 8 sequences, right? And then because they're thinking, well, I mean, usually most strings are 8 or less characters, but then if you use 10 characters, then what they have to do is eliminate this memory and then go find a memory that has 10 slots and then copy the characters that were here and put them into the next memory. And actually, we will be doing that toward the end of the semester when we talk about memory management techniques. But that you'll be coding some of that stuff later on. Yeah. Yep. hmm And you'll see that you'll gain a lot of appreciation for the Python, Java, C Sharp, C++ developers that created string objects for you, list objects. They went ahead and did all that behind the scenes. And I mean, we just use the list without thinking that all that is happening behind the scenes, but that does happen. So this reference is actually your first introduction to memory uh, concepts. Right, so okay, so that was introduction to the reference or the memory address variable, right? And then we can also create a special type of variable, a reference variable. So we can say uh, uh, reference value. Let me think. Forgot this. Is it before or after? Um, I don't type C++ code every day, so okay. And then we can say value. Okay, so give me the address of value stored in ref underscore value. So in essence, I'm creating a clone of value. So I'm creating a clone of value. So we can say ref underscore value will hold the address of value. And then we can say, well, really? Okay, so let me see what happens if I say value via ref underscore value. Okay, and let me make sure I use new line, new line. Okay, and it's not frowning at me, so I think I remembered the syntax. And then we can run it. So I thought I put a new line, but still, right? So notice right here. Oh, I put it on the wrong slot again. I'll run it again so it could be readable. Okay, so memory address of value is, oh wait, value is 5. That's this statement right here. Then I create a clone of value, creating a reference variable. And then I'm like, okay, show me, did it again over here. Show me the value via ref underscore value. And it's like, yeah, your value 5. So notice we are creating a clone. And then the next question will be, well, can you do this? Well, what address does it hold? So we're like, okay, let's check that memory address. Actually, this will be this storing. Memory address ref value is storing. Okay, memory, yeah, because it ref underscore value does not get a space in memory on the stack. Okay, so it's storing some value, but probably in a different special memory region. Okay, so then let's go ahead and run this. Okay, so memory address of value is 0x61F508. And then I want to see memory address ref value is storing. So memory address ref value is storing 61FF08. And that's why when we say, well, show me the value that you are storing at this address. And it's like, yeah, it's number 5. So if we come back here, and this is the statement auto ref value. Okay, so ref value equals value. And then if we trace it, so then this one is also pointing to that address, assuming that address was FF08, right? I know it was FFOC, but we ran the program again and it gave us a different memory location. But this is what's happening in memory. That's why when we say cout ref value without the ampersand, it displays the 5. So then what would be the next question? Mhm. That would be the next question, right? So, right, so that would be the next question. What can I modify it? And without running the program and looking at the string and what happened to Joe, we can deduce that, oh yeah, so we could modify it because we proved it with the for loop that with that memory address, it's pointing to the memory location of the original variable. So then we should be like, oh, so if I do ref value equals some value, it should uh, it should modify the value. So I'll display both. Okay, and let's go ahead and run it. It was all fun and games with loops, right? So we got to references. But actually, this is the most important concept as an introduction to memory management techniques. Because if you understand this concept, then what comes next, you'll just be building on. Okay, so notice mute. Okay, so notice right here, value is 10, right? So this is right here, this one. So we said ref value is 10, which changed the original variable value to 10. And since ref underscore value is pointing to value, its value is also 10. So if we go back and look at the memory block that I created here, this value was updated to 10. And that's the case because this one's pointing to the memory location where value is being stored in our program. Okay, 3 minutes. I'll take questions, right? That's all I want to cover today. And then in the next class, we'll take a deep dive into functions, and I'll show you different parameters we can use for functions and how we have to be careful with how we use this memory operator with uh, function parameters. So questions with this topic, this should generate some questions, right? Because it's kind of like nobody ever mentioned anything about this in Python. Python, they're just trying to introduce you to programming concepts. Programming 2, we want to reinforce those concepts, but we also want to show you how those concepts came about. Okay, that won't work. You have to, no, because so an address is an integer, right? So if we do double, it won't, like if we do integer and then double, like it won't work. So we have to work with like values. Mhm. Like values, sorry, like data types, same data types. Won't throw an error. We'll just get when you work with that value, it'll just have inconsistent data, and your program will generate logic errors, like runtime errors, incorrect values, incorrect results. No. C++ is what's called a strongly typed programming language. meaning like it gives a lot of control to developers. So it assumes that if you use an integer that you know that the largest value is 2.1 billion and change, right? So it's going to let you trip over yourself. If so, that's why like in C++, you need a lot of pre-analysis before coding to make sure you are using the correct data types. Also, once once you assign a reference variable to one variable, you cannot reassign. Say uh, I have another variable here, value 2. I cannot assign ref value down here to value 2. I can't. It'll only let me point to one variable, and it has to be for the lifetime of the program. If I wanted to point to a different variable, I have to shut down the program and then modify the code and then make this point to 2. If I'm like, well, whatever, like I don't care, like it's not giving me an error, you see, so it's not giving me an error, so it's letting me. However, it's copying the value 1 to ref value. So value is 5 here, so ref value is 5. We're saying ref value now is equal to value 2. We're not modifying the address. Instead, we're copying the value 1 into ref value. So now ref value will be value 1. So we have to keep that rule in mind. So once you assign it one time, that's the only time you can assign it. In the future, we will learn about its cousin, a more powerful guy, the pointer, and the pointer can point to different variables anytime we want to. But that'll be a few weeks from now before we get introduced to that concept. Yeah, you can do that. Okay, so that's all I have for today. If there's no more questions, and that's it. You will have a quiz on Thursday, and I guess if you are patient with me, let me shut down the recording.